Hello everyone. Mr. Slope Guy here today to help you with congruent, similar, and corresponding. So quite often when we're dealing with geometry, we deal with these terms. You're going to want to pause the video here and write down congruent figures are plane figures, meaning they lie in a two-dimensional plane. They have both the same size and same shape. Plane figures that have both the same size and shape are called congruent figures. Same size and same shape. So we have a couple examples of congruent figures here on the bottom. We have some hexagons. And we have twins. Twins. Same in size and shape. Same in size and shape. Same in size and shape. Similar figures, write this down. Similar figures are plane figures that have the same shape. Just the same shape. They can be different sizes, but they have to be the same shape. So we have two triangles that are shown here that are similar triangles. And we have two cute little penguins that are the same shape, but not necessarily the same size. So congruent, same size, same shape. Similar, same shape. So are all congruent figures also similar? All congruent meaning same size and shape. Figures also similar. Similar means same shape. Well, the definition for congruent includes the definition for similar. So that is yes, all congruent figures are also similar. Are all similar figures also congruent? Meaning all shapes that are the same shape, are they always congruent, meaning the same size and shape? Well, that is no, because you could be similar and be the same shape without necessarily being the same size. So similar figures are like an enlargement or a reduction of the original shape. So we could have what's called a dilation. A dilation, we could go from small to large as an enlargement, or we can go from a large to small as a reduction. Those are types of dilation, and they create similar figures. So the following are similar figures. They're the same shape. These two are the same shape, but not necessarily the same size. These two are the same shape, two pirate flags, but not the same size. Those are both two sets of similar figures. Two on the top are non-similar. These are not the same shape, not similar. These are both triangles, but not the same kind of triangles, same proportion. So these are not similar, even though they're both triangles. Non-similar. So which of the following is similar to the above triangle? If we look at the options of A, B, or C, which ones are similar? Well, looking for the same shape, but not necessarily the same size, I would have to go with A. A being the same shape, but not necessarily the same size. B and C are triangles, but not similar. Congruent and similar. The yellow ones are both congruent and similar. The pink, the brownish, the darker pinkish, those are all sets of congruent figures. Now, their orientation has been changed. They're not all facing the same direction. They can be turned or slid around like puzzle pieces, but they're remaining the same size and shape. They've just been moved around a little bit. So that still means they're still sets. They're still congruent, even if they're not facing the same direction. Now, corresponding means they match up. So we have two sets. We have two congruent rectangles, and we want to talk about which sides match up. And so if we're looking at side AD, that's 3 centimeters on the small rectangle, would correspond, the side that would correspond with that would be WZ. So AD on the small triangle would match with WZ. And this symbol means corresponding. So this is corresponding to line segment AD corresponds to WZ. What about WX? WX on the large rectangle would correspond with what side on the small rectangle? Well, it matches with AB. So line segment WX corresponds with line segment AB. And if we look at line segment BC, BC on the small rectangle would correspond with XY on the large. So we're matching sides. So you're like saying which part matches from the small rectangle to the large rectangle, or which part matches from the large to the small. All right, so now if we look at angles, corresponding angles, we're matching angles from two different polygons. So if we're looking at angle C on the small rectangle, angle C on the small rectangle corresponds or matches with angle Y. So we have angle C, the symbol for corresponding, and then we have the symbol for angle Y. And if we looked at angle X on the large rectangle, would match with angle B on the small triangle. So angle X corresponds angle B. So similar figures have corresponding sides that are proportional. So not only does it need to look similar, we can mathematically prove that they have the same proportion. So if I look at the relation from the corresponding sides from 5 to 10, corresponding sides 13 to 26, corresponding sides from 12 to 24, I see a pattern right away of the large rectangle is twice the small one. 5 times 2 is 10, 3 times 2 is 26, 12 times 24 is 2. And we get into dilations, we would say that has a scale factor of 2. But they all have the same scale factor. They all are being multiplied by the same number to get one triangle to the other triangle. So similar figures not just have to look the same shape, but if you're given measurements, they need to have the same proportion. So this one is actually a dilation of 2 if we go from small to large. So are these similar figures have corresponding sides that are proportional? So if I look at this, 2 and 4 are corresponding sides. 2 doubled is 4. So I would say the scale factor from this side to the other would be times 2. But if I took 5 times 2, I don't get 8. I would get 10. Or if I looked at it the other way, 8, half of 8 is 4. I'd have 4 and 2. And those numbers don't match. So even though these triangles look similar, since we have actual measurements, we can say that they are not similar, even though they look like it. Mathematically, we can prove that they're not similar because the sides are not proportional. So this one would be not similar. All right, are these two triangles congruent, similar, both, or neither? Well, let's examine what we have. We have a side of 3, matches with 3. 4 matches with 4, 3.5 matches with 3.5, 60 degrees matches with 60 degrees. I would say that they are congruent, meaning same in size and shape, which if they're congruent, they're automatically also similar, meaning they're also the same shape. So I would say they are both congruent and similar. They're proportional because they're the exact same measure on that scale factor of 1. All right, so I hope that helps you guys get started with some of the terminology of congruent, meaning same in size and shape, similar meaning the same shape but not necessarily the same size, and corresponding is where we just matched up either the sides that from two different shapes, or we matched up the angles for two different shapes to make sure that they're the same part but on a different object. Have a great day. OUT spells